Welcome to myprojectbazaar.com. Now we discuss about the product total variation regularized tensor RPCA for background subtraction from comprehensive measurements. Now we discuss the abstract for the process. Nowadays in digital image processing, background subtraction has been fundamental and widely studied task in video analysis with the wide range of application in video surveillance and the teleconferencing, and other thing is the 3D modeling. Recently motivated by this process, the comprehensive imaging background subtraction from comprehensive moments, that is the BSCM, is becoming an active research task in video surveillance. In this paper, we proposes a novel tensor-based robust principal component analysis, that is the abbreviated as an 10 RPCA approach, is for BSCM by dermoscoping the video frames into backgrounds with spatial temporal correlations and the foregrounds with spatio-temporal continuously in the tensor framework. Now in this process, the efficient algorithms using the alternating directions methods of multipliers are developed to solve the proposed models, and then the experiments on simulated and real world videos demonstrate as the superiority of the proposed approaches over the existing state of art approaches. So this process is well suitable for the saliency detection and also for the efficient fine tuning of segmentation from the background. Now we discuss the flow diagram for the process. This is the overall flow diagram for the process. In that you can see the input image module. In the input image module, the input image is taken from the dataset, which consists of the several input images in the single folder. After getting the input image from the dataset, the pre-processing is carried out. In the pre-processing module, we have to consider the three major type of pre-processing. First one is the frame conversion, and the second one is the noise filtering, and the third one is the frame resize. In the frame conversion step, at first the input video is taken, then the input video is converted into the number of images, that is known as the frame conversion. After converting the frames, the noise filtering is carried out by using the Gaussian filter method. In the noise filtering step, the filtering is used to remove the unwanted pixels or neglecting the unwanted pixels in the images, and then the frame resize is carried out. In the frame resize, the dimension of the frames are reduced by using the resize function. Then saliency map is generated by using the RPCA method. After generating the saliency map, the respected corresponding region of interest is segmented using the RPCA. After the segmentation result is estimated by using the PSNR, MSE, SSIM and F-measure methods. These are the overall parameters to calculate the efficiency of the process. Now we discuss the initial running procedure for the process. At first, open the MATLAB 2013. If you want to execute the code, select the respected path and you can see the main file.m. Right click in that file and click the third option, run. Now the dataset folder was opened. In that you can see the video. Select the video and click the button open. After clicking the button open, the video is fetched into the MATLAB. and then the selected video is displayed in the movie format. This movie player will help to run the video and also for stop and play. Now the frame conversion and the details of the frames and the frame lab will be displayed, and the filtering is also applied. Now I give the 3 as an input filtering level and click the button open. Now the filtered images are displayed in the figure 6 and the initial binary conversion are shown in the figure 8. Now in the figure 9, the segmented images is shown. The region of interest, that is the person moving in the crowd region, is only extracted, and the heat map is generated for the figure 10. In the figure 10, the saliency pattern by using the heat map is shown. Now in the figure 11, the find heat map, that is the tune find of heat map, is shown in the figure 11. The heat map is generated one by one for each frames. Now we have the totally 55 frames. The heat map is generated for the total number of 55 frames. After the 55 frames, the saliency map is generated separately for each and every frames. Now we have running the 25, 26, 27, like the saliency map is generated. After generating the saliency map, the resolution of the image is too low. So to boost up the resolution of the saliency, the figure 13 is shown. In the figure 13, the resolution of the saliency map is high. Now the final result of the saliency pattern is shown. This is the fine tune of the saliency pattern. In that you can see clearly the object are indicating in the white color and the other backgrounds will be eliminated as the black color. Now these are the estimated values shown in the graph format. Now the threshold value for the each and every frames are shown in the table, and the overall calculation for the threshold is shown in the table. Now the ROC graph for the process is nearly 0.86%. Now the estimated graph are also shown in the figure 18. Then the comparison between the existing and the proposed is shown in the figure 21. The rank of the each process is shown in the bar graph format. Thanks for watching this video.